poor frequency stability. In the second method, Armstrong method, which is indirect method, and which is basically phase modulation scheme, modulation method. In Armstrong method, indirect method, we generate FM indirectly, frequency multiplier, indirectly through frequency multiplier, WBFM. In the first step, we generate NBFM and then multiply with the help of multiplier and produce wideband FM. Multiplication is done by using frequency doubler and tripler. We done multiplication in parts, in doubling and tripling, because one shot multiplication produce large amount of harmonic distortion, because some error in the NBFM which is magnified by a particular amount, we can say by 40 or 60 at the output, which is very large. To reduce this effect, we done multiplication in parts, and then this block diagram is now break into some parts. NBFM first we generate and then multiply in parts, multiplier, which is frequency multiplier, then we use mixer here before next multiplication, multiplier, power amplifier, and transmitted. This is basically Armstrong method. Crystal oscillator. Why we use mixer here? Original message signal before NBFM carrier component is 200 kHz, deviation is 25 Hz, and apply to this multiplier. At the end, this scheme is practically use and practically FM range is 88 to 108 megahertz. In this range, to achieve this range, carrier frequency should be in the range. I took an example of 92 megahertz. To generate carrier up to 92, we have 200 kilohertz carrier. In NBFM, we have to multiply this carrier by n amount of multiplication is required. In the broadcasting purpose, some standard is set 75 kilohertz is frequency deviation for broadcasting purpose. Initially we have 25, so we want to convert this 75 kilohertz to 25. From 25, 3000 multiplication is required, large amount of multiplication required. So we done in parts, in two parts, 64 and 48. Approximate part of this to achieve 3000 is two idea. First, with the first multiplication, we multiply complete quantity with 28. Now it is converted into 12.8 megahertz, and deviation is converted into 1.6 kilohertz. After that, we use mixer. Why we use mixer here? For reason, because multiplication done in parts, because carrier frequency increase by large amount. At this point, carrier frequency increase by large amount. If now we multiply with 48, it out of the range, out of this range. To make down convert, To down convert this carrier frequency, we use mixer before next multiplication so that desired carrier frequency will be in the answer, and standard deviation also standard frequency deviation also maintain. So we use mixer here. With this block diagram, we can generate practically for broadcast purpose FM waveform. This scheme has advantage of frequency stability, but stability stability but it has disadvantage of inherent noise. Excessive inherent noise due to excessive multiplication due to large amount of multiplication involved in this, so it produces inherent noise. Now we will start FM demodulation. In the FM demodulation idea is, first we relate with FM waveform. Instantaneous angle information or frequency information is shown in this way, and complete waveform we can write in this way. If complete waveform write in this way, if it is angle modulated waveform EM, then phi t decide it is FM or PM. If it is FM, then correction amount is M alpha D alpha. If it is PM, KP MT. Correction amount is, if this much of correction amount added to the waveform, unmodulated waveform, result is angle modulation. If this much of amount, result is frequency modulation, phase modulation. It means all the information are reside or part of this waveform, angle portion of this waveform. All the information in FM signal reside in instantaneous frequency, or part of this in this part. So we want to fetch this information, reproduce this information. For reproduction, phase value is KF MT M alpha D alpha from T minus infinite to T. If we want to generate phase frequency deviation, is KF MT max, if we are considering maximum frequency deviation. So we want to fetch this component, so we have to demodulate first. If we demodulate the given waveform of FM, then we get result in this way: A KFMT sine omega CT plus KFT M alpha D alpha. Complete information in this way. Now with differentiation, all the informative portion come into the envelope portion of the message. This waveform, envelope portion, amplitude portion of the message. From this envelope portion, we can fetch this information via amplitude demodulation method, means envelope detector method. So first, in demodulation of FM, we differentiate the waveform for the purpose of information in the angle portion is come into the amplitude portion of the waveform. After that, we apply envelope detector. This procedure is known as frequency discrimination. Frequency discrimination. Frequency discrimination convert the frequency modulated signal into amplitude modulated signal by using frequency dependent circuit. By using differentiator called frequency dependent circuit, which is tuned circuit. And then original message empty can be fetched or recovered from amplitude modulated signal by using a linear diode detector or ED. Complete block diagram for this is DT plus ED is message signal. If someone apply FM waveform on it, FM demodulator. This idea to be used here. 4 type of FM demodulator are available. First, frequency discrimination. Single slope. Second one is phase discriminator. Phase discriminator idea are Foster-Sille, discriminator, ratio detector, and phased locked loop. All these schemes are used for discrimination of demodulation of FM. Except all method, except this method PLL, phase locked loop. Except this method, all the method have inductor and capacitor. Phase locked loop is not having inductor or capacitor. It is small in size. IC is available, less bulky. This is the line which shows in this way it create complexity to the system. Ratio detector is best available method to us with accuracy, but it is complex circuit. With accuracy, highest accuracy available with PLL only. Ratio detector have almost best method for analog type of frequency discrimination, analog type of frequency demodulation purpose. Now we will discuss capture effect, which is important in FM modulation. Capture effect is noise suppression characteristic. Noise suppression characteristic of FM. The signal of weak magnitude is suppressed by strong one. If two signal almost within the frequency range pass through band pass filter within the range signal, apply on FM demodulator, power difference between these two is 199 watt in case of FM, then stronger will process through demodulation and weaker will be suppressed by stronger one. In the case of AM, both are processed and in percentage term, maybe it process 80%, it process 60%, means both are processed and produce interference to each other. In the FM there is a capture effect. Due to capture effect, a signal of weak magnitude is suppressed by a strong one. Due to this feature, FM is more survival in noise condition, more immune to noise as compared to AM due to this effect. Now we will discuss next important effect, threshold effect. Effect in FM. Threshold effect. Threshold effect is denoted by this graph with some statement. Minimum carrier to noise ratio. Minimum carrier to noise ratio for which FM noise improvement is not deteriorate significantly, means I reflect the given statement from this graph between SNR in or SNR out. This straight line shows all the suppressed schemes SSB, DSBSC, VSBSC, vestigial sideband SC. If AM demodulator is two type of AM demodulators generally use square law and ED, envelope detector. ED, envelope detector. Minimum value of SNR input is required to produce SNR output. Minimum value of SNR input is required to produce SNR output. This define threshold effect, means below this value receiver can't drive. After that receiver will work in this pattern for a square law, in this pattern for envelope detector. Threshold effect, I repeat, minimum value of carrier to noise ratio for which FM's noise improvement is not deteriorate significantly, below which not deteriorate significantly, means up to this level is known as threshold. This much of minimum value is required. In all suppressed carrier scheme, no minimum level is required. For FM, I draw two more line. Minimum value of SNR required is increased now. Once it is crossed the threshold level, it work efficiently. Below that, it not work. Two line shows beta equals to 1, beta equals to 5 for particular values. Threshold effect is more severe in FM than AM. For threshold improvement in discriminator, we use pre-emphasis and de-emphasis in the circuit, or we use feedback in the circuit with PLL. We have two ideas to improve threshold effect, threshold improvement: pre-emphasis, de-emphasis. Second idea is we can improve, not eliminate. Feedback, FM demodulation with feedback means PLL. Two idea. What is pre-emphasis, de-emphasis? Two idea: pre-emphasis. First idea, pre-emphasis, de-emphasis, and second one is PLL, FM with feedback. Now we will discuss pre-emphasis, de-emphasis. Pre-emphasis is used to improve the fidelity of audio frequency range modulation. What is the fidelity? Means exactly reproduction of all spectral component is known as fidelity. We can understand this term from one more idea. We draw a diagram for audio range. PSD, power spectral density of audio. What is power spectral density? A term power per unit bandwidth is known as power spectral density. Through throughout the frequency range, power spectral density is not constant. It is variable. For initial lower component of frequency, it is higher, and for higher frequency, it is very low. Noise is also not constant. For FM, noise of power spectral density of noise is parabolic in pattern, vary with frequency. In AM and PM it is constant, rectangular. In FM it is parabolic. As frequency increase, noise also increase. So in this case, ESD of noise, in this case we mark here SNR is less than 1 because greater than 1, because in this case signal strength is more than noise. After that, noise is more than signal. For higher frequency, a particular frequency, I mark here F. From particular frequency, SNR is lower than 1. If SNR is lower than 1, then demodulation is not proper, can't possible. To make it possible for higher frequency, we have to magnify signal strength, higher frequency signal strength before modulation. For this purpose, we use pre-emphasis. We have an idea, we have to improve higher frequency signal power strength for the purpose of to maintain SNR constant. We improve higher frequency, and at demodulator side we reverse the process to restore the original value of high frequency. We use de-emphasis. The combination of these two to improve the fidelity of high and low frequency signal, use pre-emphasis, de-emphasis before modulation and after demodulation. After demodulation, so we can write some point regarding pre-emphasis and de-emphasis. Pre-emphasis and de-emphasis. Pre-emphasis consists high pass filter. De-emphasis is low pass filter. Pre-emphasis differentiator, synonym to differentiator circuit. It is synonym to indicator circuit. Boosting of high frequency component, restore high frequency component before modulation. Pre-emphasis use before modulation, it use after demodulation. De-emphasis use after demodulation. SNR will increase more than 1 for high frequency. SNR is less than 1 for original for high frequency. At receiver after demodulation, demodulation कंप्लीट होने के बाद इसको वापस लेस देन कर दिया जाता है. Now we will discuss next topic, phase modulation. Phase modulation. PM is defined as the process in which the phase of the carrier signal is vary according to amplitude of message signal. Same definition, carrier vary according to amplitude of message signal. Carrier phase vary according to amplitude of message signal. This is unmodulated carrier waveform. If this component vary, result is phase modulation. I write expression for that. Instantaneous carrier phase is proportional to mt. Remove proportionate constant. We can write in this way: basic phase kpmt. Basic phase is omega ct plus kpmt. This phase value a cos instantaneous phase. This phase value I put into unmodulated carrier, then this expression is converted into as per definition of PM. So I can rewrite this expression, this completely term placed here, omega ct plus kpmt. It means this expression shows a small amount of correction from this basic unmodulated. As per the definition, it waveform shows phase modulation. Here kp is phase sensitivity. We can write limit of this. Kp limit is radian per volt. Radian per volt. Now move to next parameters. Phase deviation. Phase deviation is come from this expression kpmt. Maximized phase deviation is maximum of this term. Maximum frequency deviation. To calculate frequency from phase, we have to differentiate this. By differentiation, we get frequency term omega c plus kpmt dash. To maximize frequency deviation, first we calculate frequency deviation, which is kpmt dash. To maximize this, idea for maximization is kpmt dash maximization. And to calculate beta, maximum frequency deviation of 1 omega m, we can rewrite all the formula for fm is xpm is for pm is a cos omega ct plus kpmt. Second one is phase frequency. Maximum frequency deviation is kpmt dash maximum. Phase deviation is kpmt maximum, and beta is maximum upon omega. Now we again calculate PM waveform. If single tone is our input, then all the parameters are revised and I directly write all the expression. xpm is a cos omega ct plus kp am cos omega mt. First, phase deviation maximum is kp mt, value of mt. Maximum value of this is am. Maximum frequency deviation is, first differentiate mt dash am omega m sin omega mt minus maximum value of this is 1. I can directly write this is mod value means no negative, no negation. Kp am omega m. For beta, Kp am omega m upon omega m. In this case, modulation index of Pm does not depend on modulating frequency, which is very important difference between Fm and Pm. In this case, modulation index does not depend on modulating frequency. In Fm, it depends on modulating frequency. We can bifurcate these two modulation scheme because these two modulation scheme are quite similar, inseparable, quite similar, inseparable because I expression are very similar but inseparable. But one difference, different definition of modulation index. If modulation index definition is changed, it might be Pm or Fm. It depends. Modulation index will decide whether it is Fm or Pm. How it is possible? Someone generate a angle modulation scheme. We don't know about whether it is Pm or Fm, whether it is Pm or it might be Fm. इन दोनों में से कुछ भी हो सकता है. How can we identify it is Pm or Fm? Because only change is correction amount phi t. If correction amount is changed, if correction amount is changed, it may be Fm, it may be Pm. But different definition of modulation index means by change of modulating frequency. If modulation index is changed, if then it is Fm. If it does not change, means it is Pm. For example, in a scheme and angle modulation scheme, if modulation index is half, by doubling modulating frequency means modulation scheme use is Fm. By doubling modulating frequency does not affect on modulation index, then it is Pm. Then it is Pm. By doubling omega m modulating frequency, Pm is unchanged. By doubling this, beta is half of previous. In this uh, in this case, it is